Hi everyone, my name is Nicola Corti. That's my Twitter handle. And thank you very much for being here. Today we're going to talk about let me write your networking code. So first, mandatory slide about my company. I'm working at Yelp. Yelp is a company based in San Francisco. Our mission is to connect people with great local businesses. We have several offices. The biggest one is like downtown SF, and then we have like a couple of other offices in Europe. I'm specifically working in a Hamburg office in Germany. And then mandatory slides about me. I'm an Android infrastructure engineer. That means that my primary role is to develop tools for other engineers, other Android engineers, and ideally make your life better. It's harder sometimes, but yeah, that's my job. I also love to call myself a community lover. I'm managing one Google developer group in Italy and a Kotlin user group in Hamburg. And those are my hobbies. So feel free to reach me out afterwards if you want to chat about one of those. But there is actually one hobby that was missing there. And I forgot to mention that I really love Corgis. So I have like a quick question for you folks. How many people here are like, dogs versus cats? How many people here love dogs? Okay, what about the cats? I'm so sorry for you folks because this talk will be extremely boring. I apologize. So talking about Corgis, I actually don't have one because I travel a lot and, having dogs around, it's sometimes harder, but I really enjoy watching videos of them on YouTube. And I think that, I would really love to get one Corgi, and let's assume like I have an endpoint, like /pet/Corgi, that allows me to get information about a Corgi. So what do? I go to the pet store, and I ask the pet store to give me one Corgi. So the pet store will happen to be located at petstore.swagger.io. And unfortunately, the pet store will tell me, you can't just get pet Corgi. You can't just come here and like drop a call to an endpoint and expect to get something back. We have like a contract. You need to have a way to interact with us. So the pet store is so polite that happens to have like a specification of all the endpoints. And to specify all the endpoints, they use a tool that is called Swagger. So how many people here actually worked with Swagger in the past? OK, great. So I'm going to do a little recap of that. So if you find Swagger, if you Google that, you will find a lot of tools related to either Swagger or OpenAPI. They're pretty similar. Historically, Swagger was a tool to define endpoints, then got acquired, got rebranded. And so nowadays, you will find the specification of the tool that is called OpenAPI. There are several versions. The latest one is version 3.0. But the version 2.0 still is referred in the community as Swagger. So if you search like Swagger, you find articles that talks about Swagger specs. They refer to the OpenAPI version 2. And also, there is a way, like, since Swagger like OpenAPI 2.0 is a bit older than the version 3, there is way more tooling. So you will find like a lot of the tools that are related to Swagger, but they just like we are talking about tools to define endpoints. To go like a little bit pragmatical, what exactly is Swagger? So Swagger is like a way to define APIs is using either JSON or YAML files. So you will have a file, and you will explain there all of your endpoints and what they can do. And why this is powerful? This is powerful because this tool, this language, is both human-readable and machine-readable. So given these, we can build infrastructure around those tools, or around those files. So let's see what the pet store defines. What's the contract that the pet store has? There is a Swagger file. So we will start with a YAML file. And there are some fields that are mandatory. So there will be like a Swagger version, in this case 2.0. There will be an info block. Inside the info block, we can put like a preamble of our API contract. So in this case, there will be like a description. This is a sample server pet store, and a version. Like the version of the server is 100. Then we can add some extra information, like the title, a contact email, the license, if I have one. This is sort of like, let's present what this contract is about. Moreover, you can specify the top level, what's the host. So this contract is deployed on a server that is at pet store Swagger IO. I can define the base path, like all my endpoints will always have /v2, and then append your path there, and you can define the schemas. Like, I'm able to answer requests of either HTTP or HTTPS. Okay, that's all, I mean, useful, but still, we are not saying anything about our contract, actually. So we need to start with a definitions block. And here, we can represent our reality. So there will be a pet, because the pet store is able to deal with pets, and there will be of type object. And we'll have some properties. So let's see some of those. First one, an ID. Type integer, format int64. There will be a name. Like every pet will also have a name of type string. Since I want to see if those pets are actually cute or not, there will probably also be pictures. So, and not only one. So I have a photo URLs property that is actually an array of strings. I can also say that some of those properties are required, so they need to be there in order to represent a pet. For example, I can say that names and photo URL are mandatory or required. Moreover, I can define the status of this pet. I can provide a description for every property, like this represents the pet status in the store, and I can also restrict the type of possible values. So, for example, I can say that the status is an enum, and can either be only available or sold. This is like pretty straightforward, but the real power of Swagger comes here. I can say that this pet has also a category. And the category, I will not define it here. I will just use a reference to another definition. Like, this pet will have inside a property, there is a category, then now I will tell you what it is. So I create a new definitions, category. Inside, I say that again is of type object. As a property, one is an ID of type integer, and there is a name of type string. So here, what I presented is two entities of my reality, a pet and a category. But again, I still haven't said how my endpoints will look like. So at the top level, I will have a path definitions, and over there I can define all my endpoints. Specifically, the pet store tells me that they have a /pet/pet ID. I can do there an HTTP call, and they allow me to do a get there. So let's provide some documentation about this endpoint, like the summary, like find pet by ID, or the description, like returns a single pet. Also, I would be interested in providing the operation ID. The operation ID, it's basically a text representation of the endpoint, because it's how I represent this endpoint, given that there are brackets and slashes, and this is a get. So this represents this exact operation. It produces JSON. So if you call that, you can expect to read something that is JSON encoded. And obviously, you can specify some parameters. For example, in this case, the pet ID that is in the path represents the ID of the pet that you want to get, is required, because you need to provide it, is of type integer, and of format int64. So here we are saying like how to make a call. But we haven't yet said what to expect back from this endpoint. So the responses. And here, the pet store tells me that there are several responses. It could either be a 200 that represents a successful operation, or a 404 that represents a pet not found. Great. So I haven't yet connected this endpoint with the definitions that I defined before. So in the 200, I probably also want to get a pet somehow. So here we can say that the 200 response is a schema, and the schema as a ref, and it's a pet. So when we do get on this endpoint, we will get an object that will comply to that definition that we presented before. So why I'm presenting you this pet store? So if you're not familiar with Swagger, pet store, it's basically the hello world of Swagger. Like, you will find a lot of tools that uses this sample set of specs. Actually, I trimmed that a lot, but they're bigger. They are like get, delete, post, some endpoints, and you can use them to play around. Also, previously, I mentioned about the tooling around Swagger. There are some tools that are really cool if you need to onboard on Swagger, specifically Swagger UI. Swagger UI allows you to have like a website representation of your spec that you can like host somewhere on your web server and see actually what every endpoint is doing. You can like find them. Let's go to get pet ID, and you can find like all the parameters and how the body of the response will look like, and it's a really great tool for documentation. And another tool that it's really great is the Swagger editor. So the Swagger editor, it's really similar to Swagger UI, but at the same time, it allows you also to edit the spec and see in real time how they will look like. So if we try to add a new endpoint like /Corgi, it will like autocomplete here, and it will tell me, hey, there are errors because summary and description are empty. So you type that, and once you finish typing, the error will disappear, and you will see your new endpoint and how it will look like on Swagger UI. So I find those kind of tools really great to have like an iterative approach when writing your Swagger specs. So the first thing that we learned from this is that I can't just call /pet /corgi because the parameter, the pet ID, was of type integer, int64. So this endpoint is not valid. I need to call something like this, /pet /42. OK, so now we know how to talk with our server. But how do we actually implement this? So some weeks ago, I tweeted this question. It's like, so folks, how do you make a network request and parse the results using only whatever is inside the Android framework? No retrofit, no Rx Java, no Moshi, no JSON, no whatsoever. I got some interesting answers that I'm happy to share with you now. The first one is like, people told me, hey, is everything OK? Blink twice if you need rescue. Yeah, sure. Also, that sounds like a really great job interview coding challenge. And it is. This one is gorgeous. It's like zip all the data of your API and put it in the asset folder. Make a new release as soon as your backend data changes. Instant offline support for free. That's brilliant. Come on. And then like, yeah, like you can fake being ill for long enough that someone else has to do it for you. Those are all inspiring and funny also. But actually, the real answer is something like this. So you will have to use this HTTP URL connection class. You get the body. Then you can convert the JSON with this JSON object class. Pay attention that you need to use the JSON with all the capital letters, because this is the one from Android. And then you can create your class like reading field by field. And I tried to do that. And the code looks something like this. You're not supposed to read it. Just notice that that guy here on the bottom left is a Pojo. So being an Android developer means like, putting layer of evolution on our code base, like applying new libraries. And if we start applying like Kotlin, the code will look like this. Maybe also we don't want to do the parsing by hand. We want to use a parsing library like Moshi. The code will look like that. We also probably want to use OKHTTP as HTTP client, and the code will look like that. And we also know that we can use tools to abstract our network calls like Retrofit, and the code will look like that. So what we actually did at Yelp, we put another layer of abstraction on top to make sure that our Android engineers, the only thing that they need to call is this. They have a function, they pass the parameter, and they will get a result. They don't need to write retrofit code anymore. How we did that? We leveraged a tool that is part of the Swagger pipeline that is called Swagger Codegen. Swagger Codegen is a tool that allows you to generate code from the Swagger spec is actually open source, and it allows you to generate both the server stubs, so you could also generate like server implementation of your endpoints, and the client libraries. So like libraries for Java, Android, every other language that you need. So it's open source. I really invite you to take a look. It's on Swagger API, Swagger Kotlin. It's kind of complicated, but just like to have an understanding on what's inside the tool, we can define the code base in two big families. Let's say there is the generator and the template. The generator is like Java classes that reads and parses your Swagger spec and populates all the fields inside the Java module. And templates is like template files that will be populated with the value that are parsed. There are actually several templates already available online that you can start using. And this tool is mostly a command line tool. And when I say command line, I mean something like this. You should call it with java-jar, Swagger Kotlin, generate, and then with -l, you can specify which template you want to use. Like in this case, I would love to generate Spring capable libraries. It's okay, it's really flexible, but it doesn't really play well with an Android build. And the second thing is, like I mentioned, that there are a lot of templates already available. This is the list. And if you see here, there is a Kotlin one over there on the right. And there is also a Retrofit, Retrofit 1 and Retrofit 2. But those are not in Kotlin. So what if I want Retrofit, but in Kotlin? It's not there, so either I have to compromise or I have to create my own templates. And templates are stuff like that. No syntax alighting, because they are templates. Like this is supposed to be kind of a Java code. I mean, this will generate Java code at a certain point. But the problem is that, like, you know, there are like all of those tags that will be replaced. And the logic here, it's really, really basic. Like, just to give you a little idea of what is this about, like in this case, what are we saying here is that if there is a description, print those characters like backslash, asterisk, space, print the description, print those characters, and remove it. Close the logical block of description. So this templating language is called Mustache. I find it to be like, yeah, flexible, but still like you have to fight a little bit with that, and you have to maintain your own templates. And so this is what we did. We created Swagger Gradle Kotlin. So it's open source. It's on GitHub. You will find it on Yelp, Swagger Gradle Kotlin. And it's basically a Gradle plugin that wraps around Swagger Kotlin. So how is it? The first thing, yeah, it's a Gradle plugin, so you don't need to call it with the command line. You don't need to invoke the tool with the command line. You can just plug it inside your build. It's input-output aware. So if your Swagger specs are not changing, it will not rebuild anything because things are already built. You don't need to rebuild. Also, the idea around this plugin is to simplify the API offered by Swagger Kotlin. Swagger Kotlin wants to like support all the possible languages and all the possible templates, while the feature set of our problem, it's smaller, and we mostly want to support client library generation. So we try to simplify as much as possible the API. And also the second thing, we built this tool to solve our problem. I'm not here to sell you this tool. I'm here to tell you how, like, the challenges that we got. This might solve your problem as well, because we use the stack that is pretty famous in the Android developer environment, like Kotlin, RX Java 2, Retrofit, Moshi, 13 ABP. Those are like standard and big libraries. But if you're using coroutines, or if you're not using Kotlin, the code that you generate, you can't actually use it. So let's see the spec that we saw before. And let's have an idea of what we will get out of those specs. Let's start from the small one, the category. So the category will generate a Kotlin class. Given that we have Kotlin, we also want to generate a data class. So we'll get like the clone, the is equals, and all those Andy methods out of the box. There will be two fields, like ID, two properties, like ID and name. The type will be resolved using the format. So for example, the ID will be long, and the name will be string. They're not required, so they will be nullable. And given that they're nullable, I can also already instantiate them with null. I'm using Moshi, so I also want to annotate those classes with @JSON to make sure that the parsing is consistent. I need to import the proper stuff from JSON, from Moshi. And also, if the maintainer of your spec is polite enough to provide description, like, hey, this is a category and represents a category used to group pets, you will also have those description inside the generated code as kdoc comments. Let's take the big class, pet. So what we will have? We will have something like this, a data class, pet, that will have some field. There are some interesting things to see here. The name, for example, is a string but was required, so it's not nullable, and I can't initialize that. That's consistent with the spec. The photo URLs was an array, but in Kotlin, we decided to convert it to a list. The category was a reference to another definition and was not required, so it will be like a category question mark. And the status was an enum, so here we create an enum that we actually have like inside the data class with all the possible values. Again, if you have description, you will have like a class that looks like that is like easier to use, and your developers will better understand what they're dealing with. Let's take the endpoint. /pet/pet ID. Let's see what we generate. So we generate a retrofit interface that has a function, and in this case, for the function, we happen to use the operation ID because it's, again, a text representation of our endpoint. We will have all the parameters. In this case, the pet ID will be annotated with the retrofit path annotation. And we annotate @get with the endpoint to make sure that we call actually a get. Also, we are using Rx Java 2. So in this case, this endpoint will return a single of a pet. And the last thing, this is like something that we use internally. Every endpoint will have this X operation ID header, and we pass the operation ID as a header. This is useful for us because we use that internally for logging. And we with this code generation, we make sure that this is consistent and it's generated by the machine. Developers don't have to write it. And again, if you have description for all the parameters, you will also have like a fancy kdoc comment over there. And the final class will look something like this. So what are the use cases of this tool? So you can use it if you have a small application and you have the Swagger spec to you can plug this Gradle plugin in your app module, and you can create code and have it inside a package wherever you need it. Or you can create a pure Kotlin module and let the Swagger spec be there and the generated code live inside that module. You can actually have like a library project. You can have like create a new Android Studio project, have only the Swagger spec there, build, and open the project, publish that on Maven local, and use it. Or the best thing, like integrate it inside your CI. And that's actually what we did and what I'm going to present. So the way how you use this Gradle plugin is something like this. It's published on Gradle plugin portal. You will use it with the class path directive. And it requires you to specify a generate Swagger block. The only thing that is needed there is the Swagger spec file. Like this guy is not able to work if you don't give Swagger specs. We're talking about code generation from Swagger specs, so that's the only required property. All the others have default, and you can like customize them if you need. For example, the output directory of the generated code, the platform, spec name, spec versions, whatsoever. So what this plugin will do, it's nothing more than creating a new Gradle task for you. That one, generate Swagger. And we intentionally decided to do not plug it anywhere. So this task will not run unless you decide to intentionally run it. It's up to you to decide if you want to do something like this. Like pre-built depends on tasks get my name, generate Swagger. In this case, you will call this task every time before your build. Given that this Gradle plugin is input-output aware, something like this will happen. When you build, like the first time the code will be generated, and the second time your build will look something like this. So there will be this generate Swagger task that says, I'm up to date. Like the Swagger spec, I haven't changed. The build code is there, it's still there. You haven't deleted, so I don't need to run again. And I'm up to date. Just go ahead. So let's see actually how we integrated this Gradle plugin within our infrastructure. So to explain this, I need to give a little bit of context. At Yelp, we have several Android applications and several iOS applications. But I'm going to focus mostly on two. The first one is the consumer app. It's the app that you can use to search for restaurants, leave reviews, upload photos, whatsoever. And the second one is the business owner app. The business owner app is the app that if you own a restaurant, if you own a business, you can use, claim a business, and like answer to reviews, answer to messages. To give you some statistics, the consumer app hits a backend service that we call mobile API service and has nearly 400 endpoints, while the Biz app hits a backend service that is called Biz app service, and there are like nearly 100 endpoints. So we have Swagger specs for both of those two services. So whenever one of those two Swagger spec file gets changed, it gets committed inside a repo, a new build on Jenkins will get triggered. So what Jenkins will produce some artifacts, specifically an Android artifacts. And as a side note, we use this tool also to generate Swift code for our iOS application. So this is out of the scope of this talk because I'm going to talk, this is mostly about Android. But yeah, it's probably like worth to say that you can use this tool also for building other client code. The iOS code specifically will be committed inside a Cocoa pod, and the Android one will generate an Android library that we upload on our internal Nexus. So the developers at Yelp will use something that is like this. They will have like an implementation, dependency, com Yelp Android APIs, mobile API, that's the version, and the same thing for Biz app. The interesting thing to notice here is this one. So the version. At Yelp, we change our Swagger spec multiple times a day, and we use the date, like human readable date, as a version. That's just to don't get crazy with versioning, because if, 10 guys within one day are actually committing on that line, they will all have merge conflicts. So we use that. And on the Swagger CodeGen side, we use that Swagger spec version as a version of our Android library. Why I'm saying this? Because this allows us to have all the history of all the generated library ever generated at Yelp, and allows me to go back in time and see like, oh, that's Swagger spec from last week. Let me see which library got generated out of that, and I can easily find it with that. Find inside this artifact, they will basically find several retrofit interfaces, like default API, pet API, business API, whatsoever, and all the Kotlin data classes. So what's the power of this? I want to stress it again. This is generated. Means that you can see that on Android Studio, but you can't change it. And you can't imagine how many problems we had, because developers, they type it wrong, the operation ID. So on our side, we say like, oh, this endpoint is not called anymore on this version. What's happening? And actually, oh, we are hitting the wrong endpoint. We are doing a put instead of a post, or we just type it wrong, the operation ID. So with this tool, you are sure that the code that you have in the Android app or in the iOS app reflects what the Swagger spec says. So obviously, there were some challenges and problems that we faced that I want to share with you, and also some future improvements. So challenges. The first thing is breaking changes. So what happens if I have this endpoint? There is /pet ID that has a parameter, like just one parameter. I code the app. Then at a certain point, the backend engineer decides that there will be another parameter. So another engineer from another team will bump the library, and the app will not compile anymore. That's actually, I mean, something that you need to educate your Android engineer with. They need to know that, hey, this reflects the Swagger spec. You can go in the Swagger spec and see what happened, and you're probably like, ideally, we try to make teams responsible of changes to the Swagger spec and also changes inside the Android code base. But this was like an easy breaking changes. You can have scenarios that are actually worse, like this one. Let's say you have like a /pet/owner, and you have endpoint, and you have two parameters, name and surname, both of type string. And for whatever reason, you publish a new version of the generated library, and they're like that. The app will still compile, but you will actually send the value of surname as name and vice versa. So you need tooling around your Swagger spec to make sure that those kind of changes don't get propagated inside the generated library, because you will have problem. What we did is like we have a strong pipeline of pre-commit hooks that tries to like catch those kind of scenarios, but you need to be aware that you are generating code, and if the generated code changes, you will not see a pull request with that changes. Also, defining names. So with 500 endpoints, I will let you imagine how many objects we actually have. Thousands. Some of those, I mean, when we started working on these projects, some of those objects, they not even had a name. They were just like defined inside the response. Like inside the response, locally, you can define, hey, you will get like an object that has true properties, these and that. Okay, so which classes I generate for you in Kotlin? What's the name? So you need to be like, you know, find some inspiration and create names sometimes. So we ended up with stuff like ID to predicted BizInfo for photo upload suggestion map to business review map. That's not actually true. I just like took random names, but we ended up with really long names. And fun fact, we actually hit. I mean, with these, I learned that on the JVM, you can't actually have classes that have names that are longer than 255 characters. And I learned that just because we hit that limit. Because if you start generating names by appending context, you can end up in something like this. So what we did now, we enforce on our Swagger spec that all the objects should have a name. Like they can be defined locally, but locally they need also to have a name. Otherwise, we can't generate code for that. And the other challenge, that sounds stupid, but is actually kind of tricky. How do you access the raw response? Like, one developer once came to me and said, like, you know what? I need to access one response header that the backend engineer is setting for me because I need to use it for doing something. That's the code. It returns a single of an owner. It's the body. It's already parsed. How do I get there? So in Retrofit, you will do something like this. Single of result. You can wrap the response type within a result, and that will allow you to access like the raw body and the response headers. But the problem here is that I have 500 endpoints. I don't know if I want to have result there for all the endpoints just because one engineer came to me. So we don't have solutions for these yet. What we're trying to do is on the Swagger spec, you can also specify in the response if there are like meaningful information. Like in the response, you could say like, that's the body, and there will also be an header. And the idea is like, try to understand from the Swagger spec if there are like extra information, like response headers, whatsoever, and if so, either create 2 functions on the interface or just like have the one only with the result. We still don't know. And so for the future, there are like some things that are like planned. They might not happen, or they might happen. The first thing is support inheritance. So in the Swagger spec, what you can say is that /pet ID could return either a dog or a cat. This is impossible with what we created so far for one single reason. We're using Kotlin data classes, and they can't inherit from each other. So they can inherit from other non-data classes. So we will need to like change a little bit the generated code to have like either open classes or abstract classes that contains like the set of all the common properties, and then like the leaf of the hierarchy will actually be data classes. Coroutines. Like if you saw the talk before from Boris, he was talking about like how coroutines and Retrofit plays well together. Everything I showed you was with Rx Java 2, and we did that just because our code base, it's pretty big. We are talking about millions of lines of code, and we are really like, let's say, connected to Rx Java 2, so we can't just say like, no, let's do everything in coroutine. So we plan to support another template in the near future that will, instead of generating like single of pet, we'll have like function that returns deferred of pet or suspend functions. Also, the iOS template is not yet online, just because we felt more comfortable so far open sourcing only the Android one. And yeah, it's in the pipeline. Yeah, and then the future thing for me is actually getting a Corgi at a certain point. That was all for me today. Thank you very much for being here. Yeah.